It's fun to build these dynamic LED patterns, and now having looked at three types of patterns, we are going to create one more here, and this time focusing on the bitwise OR operator. Notice in this case, every LED lights up from right to left, and then everything goes back to being, let's say, just one LED. And now we are going to do this with the bitwise OR operator, as we'll see in this video. The idea here is that I'll start with just one bit, so set that to 1. I will then OR it with, let's say, 1 on this bit. So remember, when I OR this and this, these two will become 1. Then I'll OR these two with, let's say, a single 1 here, which will make these 3 as 1, and so on and so forth. The entire panel will light up. Of course, once I reach here, I'll just come back to this point. So this is going to illustrate bitwise OR. Let's see how we do it. So I'm just going to say, look, if my style is, say, 4. So let's say the style is, say, 4. Then I'll start with a pattern of, say, 0 0 0 0 0 0 0 0 0 0 0 1. Now I'm of course going to set the style to 4 over here. Now since we need to update the pattern, I just put, let's say, one more of these conditions here. So I just go and say Control C to say Control V. If style is equal to 4, 4, I want to do, let's say, OR. Let's just remove this toggle. So what I want to do is that I want to OR this with a single bit at all times. So I will just go and say, look, I want to OR this with, let's say, I want to do a bitwise OR of this with 1 left shifted by CNT modulo. Now let's just understand what's going on here. Remember, count is a counter variable going from 0, 1, 2, 3, 4, and so on and so forth, which means count modulo 8 is going from 0 until 7. So what I'm trying to do is that I'm saying that, look, let me OR this pattern with 1 left shift with, let's say, 0, 1 left shift with, let's say, 1, 1 left shift with 2, and so on and so forth, which is basically saying that, look, B0 being 1, B1 being 1, B2 being 1, and so on and so forth. I'll keep ANDing this all the time. And as before, if my pattern becomes equal to, let's say, all ones, so, if pattern is equal to 0, B, let's say, 1, 1, 1, 1, 1, 1, 1, 1, let me be careful here, 1, 1, 1, 1, 1, 1, 1, 1, I can then go and, let's say, reset it to, being whatever it was. So I just go and say pattern is reset back to, say, 0, B 0 0 0 0 0 0 0 0. So when I run this code, it's quite interesting. In fact, the pattern starts to form, but you notice that the last bit is not getting. Now, why does this happen? Because think about it. When pattern becomes 1 1 1 1 1 1 1 1, in fact, immediately it gets set to 0 0 0, and that's why the last bit is not shown. From, let's say, from this point, I go back immediately 0. The way to fix this would be, well, I must make sure that this 1 1 1 1 is also shown before I reset back to 0. Think through this. The solution to this problem is quite simple. I will just invert these two. So which means I will first check for the condition of being 1 1 1 1 1 1 1 1. I'll set it to 0 if that is the case. Otherwise, I'll let it be. Now when I look at this code, it's pretty cool because all the bits get set and I go back all the way to 0. Now let's say I want to try something different. I want to start exactly the reverse. So I start from bit 1 and have it getting filled up from, let's say, left to right. Now this is actually quite interesting. So I'll just change my pattern here to start with. Let's say I'll just copy this and so that I have it available here. I will just go and say, look, 1 0 0 0 0, all zeros. Now think about it. I want to do an OR first with, let's say, single bit B7, single bit B6, single bit B5, and so on and so forth, which means that I can do exactly the reverse of what I'm doing here. Instead of doing 1 and left shift count modulo 8, in fact, I can do something quite interesting here. I can go and say pattern or bitwise or with 128 right shift with count modulo 8. In fact, I'll just go and comment this out. Think through this. Basically what's going on, remember this bit represents 128. So I'm going to this bit, then I'm going to this bit, then I'm going to this bit, then I'm going to this bit, and so on and so forth. Everything else remains exactly the same. When I run this piece of code, you notice the whole pattern has completely changed. It is going exactly in the reverse direction. Very happy to discuss this, but do think through this. Very, very interesting usage of bitwise operators. In fact, this brings me also to the end of the activity. It's been a long, long journey. We have navigated a lot of concepts through this, but I hope it's been fun because this is really something different, something new, and we are applying it in a pretty interesting manner. As always, this activity can be extended in multiple ways. You can apply, you can try to, let's say, write functions using bitwise operators. You can apply these functions with LED patterns. So pretty interesting. You can have like bits jump around in multiple ways. You can combine LED patterns to create new ones, as we saw some examples. You can consider many, many LEDs together. You can consider different new functions. Like I said, you can consider color LEDs. So instead of just red, you can say, okay, I'll use a pattern here, set the turtle color using RGB or hex values. Basically, I control R, G, and B, just like I'm controlling R and B. Principles remain the same, but much more interesting stuff can be built. And you can also go further with the image. So lots and lots of things you can do. Enjoy this journey because most important is be systematic, learn in a step-by-step manner, and enjoy this journey. Bitwise operators are somewhat new, but you can clearly see that they are useful as we saw in our activity. In general, this way of learning where we learn systematically in a step-by-step manner, highlight the concepts, apply concepts into activities. If you think this is fun, this is effective, look at our website www.yby.it because that is how we learn Python programming. Take care. Thank you so much. Bye bye.